Welcome to Video Lectures, Section 5D, Graphics in the Media. The first example is about multiple bar graphs. This is where you can show two or more sets of data, and it makes it really easy to compare the two. This is some made-up data for BYU Idaho students who like flip-flops despite them being against the honor code, and the years provided. And we'll say this is frequency in hundreds. And we can easily compare men, which are blue, to the women, which are kind of a red-pink. The next one is stack plots. This is where the information is all stacked one upon the other, and the height of the color you're seeing is the amount of information or frequency for these different categories. So if I wanted to find, let's say, the number of articles downloaded or imported on Google in April of 2009, I would come to April 2009 and find the height or the width of this purple for Google, and it looks, I don't know, about 14-ish, a little under the halfway mark, and this a little under the halfway, so probably 3, so about the height of 11, let's say. And it doesn't give us a key, so I'm guessing maybe 11,000, something to that effect. And so that way you can find the actual number versus this one that just gives it to you. Here's another example of a stack plot. And a stacked bar graph is very similar in that it's separating the information stacked upon itself, but it's separating the categories within each of these. So for 2002, 2003, 2004, and so forth. The next kind of data would be graphical or geographical. And so we can take some sort of a map, and in this one we have mortgage delinquencies, and it's broken up in states but also in counties. Another one, we could just talk about the elections and how just recently we had an election, and they will show some of them the states turning blue or red according to which candidate won that state. You can also have averages on temperature or contour maps and different ways of showing geographical data. And it doesn't have to just be the United States. The next is 3D, and we're going to talk about the graphics versus a 3D graph. Now, I think a lot of you know how to do graphs in Excel, but I'm going to go ahead and go through it anyway. Here's my data, and we're going to come into Excel and just throw in some really random numbers. And so I have my categories of men and women. If I had a third, I could put that in as well, for children or whatever kind of information you're creating. To create a 3D graph, I can come into here like columns, and because I have my 2, I want to do my 2 next to each other, but you'll notice that it has 3D column. So I'll press that, and I all of a sudden have a 3D graph. I can even change it to make it look more 3D. I can rotate those a little bit so that it looks more like that. I can change the design, and there we go. We have a 3D graph, right? Well, not really. We're still only comparing two data points, year and frequency, or the number of, and we can put in those keys over here by changing. There we go. We can put that in over here, saying the number of BYU Idaho students who like flip-flops, and down here the year, and give it a title. But this is truly not a 3D graph. It just makes it look fancy, and you can do that on your other assignments. However, it just dresses up two-dimensional information, making it look fancy. A true 3D graph uses 3 data points to create each point on the graph. These are known as the X, Y, and Z axis, and you need 3 data points. I like this one best, or you can use the one from your book example, and I'll bring that up later. Here's one that has 3 specific data points for every single point you see in this graph in the blue, the green, or the red line. And this right here coordinates with the number of sales in the date 7/2011 for the sales total, I believe that says. Let's make this a little bit bigger so I can read those. So we have the sales in total for pounds, shipments, and the invoices. So we have 3 sets of data points for every single point on this graph. So this one would be invoices for the year 2000 or for the month June 2011, and it gives me the quantity over here. So I have 3 data points, and the only way to show those 3 data points is within a 3D graph, not just making it look nice and pretty and dress it up. All right, the next one is combination graphs. This is where I have 2 of my graphs kind of put together. In this case, I have a bar and a line graph or a line chart. The example used in your book has a line and a pie chart together, and it shows different information. In this case, I have the average temperature for some city versus the precipitation through a year from January to December. Beware of perceptual distortions. Here's one perceptual distortion. My graph here is really talking about the height of this trash from 1960, 1980 to the year 2000. The amount of trash is going up per capita. However, because of this graphic, it's getting larger, and therefore the area is increasing because area is length times width, or in this case, the height times the width, and it is increasing when really I just need to be looking at the height. So beware of that because it looks much, much bigger when it's not as much. Another caution is to watch for the scales. Notice where this is starting at 7.6 and ending at 9.5. We're missing all of the information from 0 to 7.6. And you're thinking, well, it doesn't matter, right? However, if we were to back up a little bit, then these all would be much closer together. So beware of that scale. Something that can look like it's 50% higher than something else could just be that it's only one unit higher, and it's the scale that's off. The next is percent change graphs, and I'm going to go ahead and bring up your book because I couldn't find a really good percent change graph. So I'm going to use our example here. We can see this line graph or line chart showing all the information on the changes in college costs of public versus private. But these are percentages, right? So the percentages are changing, and it looks like the public has this massive jump versus the private, which ends up going down, right? Well, that's the percent change. Notice over here, the public, yeah, it goes up a little, and so the percent change does change, but here, the actual cost is much higher for the private. The next thing we're going to talk about is pictographs, and we have some examples in your book here. A pictograph can, sometimes it can add, but in most cases it's just making it look pretty and fancy. So here's one example of just showing something pretty to make your graph look pretty. I have another one here that just makes your graph decorative. Another way of calling it is embellishments. Sometimes it can be distracting, so beware of pictographs as well. All right, that is section 5D. I hope you join me for the next section.